Hi and welcome back to Neural Splendor. Tonight I want to talk about the Cummins QSB 59 and ISB 59. Q is off highway, I is generally on highway. We're going to talk about the VP44 pump and the VP30 pump. The VP30 is the little brother to the VP44. Generally speaking, the VP44 was about 190 horse to 275, and that was about the max for that pump and that engine at the time. And then the VP30 would be somewhere, say, 160 to maybe 210 or 230 horse max. And the situation we're talking about is a crane, so it's a QSB, and it was random stalling, so also called unintended shutdown. And then a key cycle, which just means hit the starter, it would start right back up. So let's take a look and see why we had unintended shutdown happening on this crane while it was working at a job. To make this video brief, we're not going to get into the dynamics of how the pump and electronics work, but the picture that you see up here is a data log, and there's a couple different voltages on this engine. You've got standard battery voltage at the processor that runs the engine, also called the ECU, and then the VP44 has its own processor, and you can see here that we've got VP44 voltage. And if you look at the battery voltage, you'll notice that it is about 13.2 volts while the engine's running, and the voltage of the VP44 processor is about 9 volts, and that's too low. So I'm going to take this data log, section of data log that I parsed, and I'm going to show you on a graph what we found and why the problem happened. So here I've converted what you saw in that spreadsheet into a graph, and up at the top we've got the actual battery voltage to the engine. That's what the engine ECU is seeing, and that's about 13.2. Our next line is the pump processor voltage, and that is really the lowest voltage that pump should see. So that's just a tad below 10 volts, and that's really too low, but the pump was running at that voltage level. And down on the bottom, we see where the voltage dropped right down to 0, where the red arrow is, and that is where the engine would stall. So the voltage on that pump should always be about 2 to 3 volts less than battery voltage that the ECM sees. And if it's lower than that, you can start having trouble with missing in performance, and then when it drops low enough, your engine just stops running. The VP44 pump processor reports back to the engine ECU the voltage drop that it sees. So the ECU knows battery voltage, and then the pump reports the voltage that it sees, and then voltage drop is calculated in there. In the graph that I showed you where voltage drop went to 0, the pump processor actually went to sleep, because it always displays the voltage drop as compared to battery voltage. So you notice that the voltage drop was almost 4 volts, or right at 4 volts most of the time, which was way too much. The problem we found was there's a relay that feeds the voltage to that pump processor, and that relay is turned on and off by the engine ECU. It's actually a safety shutdown for emergency overspeed or engine runaway. And there's a fuse that supplies battery power to that relay. Well, that fuse was corroded in the socket. We pulled it out, cleaned the contacts, put a new fuse in. Our voltage drop went to 2.1 and the problem was corrected. Thanks for joining us at Neural Splendor. See you next time.